I'm here to talk about LLVM Premerge testing. Also, Aiden Grossman is going to join me to explain some of the new stuff that's going on. So at Google, I've been at Google for 14 years, and this joke never stops being funny at Google, which is that there's always a choice between two systems at Google, the one that is deprecated and the one that isn't ready yet. And I think the reason this joke stays such a reliable workhorse is that it's just way too often true for internal systems. I mean, this is one of the challenges, right, of operating at a big scale and having to run everything while you're also trying to rebuild it and replace it and refresh it, is that you're constantly kind of trying to rebuild the boat while you're sailing on it, so the boat is both deprecated and not ready yet at all times. And it's very much the case for the pre-submit infrastructure or the pre-merge infrastructure. Just to clarify, I use those terms pretty interchangeably in this talk because we call it pre-submit internally, and then we often call it pre-merge externally. So let's talk a little bit about the deprecated thing, which is the current pre-merge infrastructure. And just to review, so let's say you've uploaded a PR to GitHub to change some part of LLVM. You get a lot of details here, but the one that I'm kind of want to draw attention to is this build kite / GitHub pull requests. I just picked a build at random on GitHub, by the way. It isn't representative of anything. And you'll see that there's this little details box. And you don't have to, you can just be an open consumer. You don't need any special permissions to look at this. But if you click on that, that's going to take you to build kite. And in build kite here, you'll see a couple of things. It took me a minute to figure out how to read this web page. So you'll see that there's a Linux build that's queued. That's that little clock there. And then you'll have a Windows build that is that's just currently executing here. It's been running for 15 minutes. The whole process, end to end, has been running. And what happened, if we're looking down here, I'm going to zoom in a little bit. What happened is that it waited for 9 seconds and ran in 15 seconds this script that's actually checked into the LLVM repository. So you can go look at .ci/generate build kite pipeline premerge. It's a shell script, and it basically tries to, just looking at the paths of the files that you've changed in your PR, it's trying to determine what tests might be appropriate, if any, to run as part of the premerge, right? So it's a build script. It's a little, if you're testing premerge, the thing you learn quickly to do is to bypass the script and just always run the premerge so that you can see what's going on. But that's where that script lives. You can check it out at your leisure. Runs quickly, obviously. And then we have a situation here where it determined that in this case it needed to test on both Linux and Windows, and it needed to test pretty much everything: Clang, LLD, Clang tools, extra, compiler RT, LLVM, check all, check Clang, etc. So this is a pretty big build job that we've ordered here. And you'll see that it waited for 9 seconds, meaning it basically didn't wait at all, and then it ran in 23 minutes on the Windows machine. And it's still waiting after 36 minutes for a Linux machine. So I took this sort of during the peak development cycle. You'll find if you look at premerge testing, it's pretty strongly diurnal around sort of West Coast working hours, professional working hours, Monday through Friday, sort of 9 Pacific to 5 Pacific. Really, if we're being honest, more like 11 Pacific to 7 Pacific, the typical programmer productivity window. So if you recall, earlier in the year, there was some real concerns about Windows queuing delays actually becoming, pretty unworkable during peak. We were talking sometimes the queue wouldn't totally clear during the day. So we're talking, multiple hour queue times for Windows jobs. And so we threw a bunch of computers at the Windows system to try to put out the fire. And so now I almost never see any queuing delays at all on Windows, but Windows queuing delays are still, we added an additional machine and they're still not great. And so they're still grumbling from folks about that. And then if you go and look, and this you can't do, this is from the Kubernetes instance. So the way this works is, right, you upload a PR to GitHub, that sends a webhook over to build kite. It's the little Rube Goldberg machine right now. Build kite then runs that script and fires off builds to Google Cloud, a Kubernetes instance that's running both on Windows and and Linux. And then these are the machines, the Linux machines. And you can see that they're pretty much pegged, except for just instantaneously when I took this one, I think was probably between builds. Or there's actually a section of the build where that's not very parallel. I think probably running the lit tests where it, like the utilization drops, and you can kind of see that cycle. If you squint here, you'll see the machines stay very busy for a while, and they kind of drop off, and then they get very busy again. So, I mean, these machines are running just pretty much flat out as much as they can, using as much bandwidth as the LLVM test will use of a computer, pretty much continuously during those peak times. And there's a number of problems, with the current infrastructure. And I didn't spend a lot of time making this slide. I just kind of top of mind, and we could probably spend a whole half hour just gathering other problems from the community about the pre-submit infrastructure. But there's no auto scaling. So the machines are on all the time, which, this kind of makes talking about capacity planning extra hard, because if you're paying to keep these machines running over the weekend, when they're not really being used, and then they're being used flat out, you kind of have to average those two things into a certain amount of machine capacity for fixed spend, right? And so that means that our queuing delays are worse than they probably could be if we were only turning on computers when we needed them, right? And then we could be a little more efficient with that. There's no analytics, so everything that I just told you is all like eyeball, statistics. Like I go and I look at, the last 14 days on cloud, and nobody else can look at that stuff, right now, and because it's locked down, or we talk about, what's the average queuing delay? Well, I think we can qualitatively say, well, they're getting worse or they're getting better, but you can't really quantitatively say it. You can go to BuildKite, and if you have the right permissions, you can look at what the machines are doing right now, how long the jobs have been waiting that they're currently working on. But beyond that, so it's kind of a sense of how the infrastructure is working, and also because there's no analytics, there's no alerting. So I get Discord notifications from people who are like, hey, have you noticed that this thing has been busted for 2 days? And no. This is also how I continue to discover parts of LLVM's infrastructure that are hosted by Google. Is somebody's like, I'm really upset. This machine that I rely on has been down for 2 weeks, and I'm like, I've never even heard of that. And I talk to my colleagues, and I'm like, are you aware that we're hosting this thing? And they're like, no. And then I have to go find it. And then there's stability gremlins. I think there was an escalation recently to reboot one of the Windows machines. It was just failing a bunch of jobs, so Aiden hopped on and did that very graciously. But it's requiring a lot of manual intervention, right, constantly. And then I know there's been a lot of discussion. This isn't necessarily a problem, but I would say it's a requirement, which is with the move of LLVM to GitHub, the BuildKite step is feeling a little superfluous, right? We could invoke these builds directly from GitHub. That might make the user feedback in GitHub a little bit better too, and a little bit more timely. And it just increases the reliability of the system, right? Because information doesn't have to pass through this middle system to end up, sort of where it needs to go in the Google Cloud instances. And then, then there's a bunch of usability and inclusion problems in the sense that this isn't really a community-driven project right now. There are certain parts of this where you have to be a Googler to work on it. The documentation is unclear. A lot of it's out of date. It's in a separate repository, and it's fairly opaque about how to use it, I would say. So together, that's kind of why things are, in my opinion, the way they are right now. But we've been slowly trying to make improvements here. So that's the current system. I'm going to bring Aiden up on the stage to talk about the not ready yet system, which is actually hopefully ready really soon.
Yeah, so after the past couple months, we've been working on the new system where essentially instead of using BuildKite, we're looking at using GitHub Actions directly. So using GitHub Actions and then running those jobs in a self-hosted runner cluster. So essentially taking a Kubernetes cluster just like BuildKite runs on, except instead of running a bunch of BuildKite agents, we run a GitHub self-hosted runner instance that ends up running everything. So the new flow essentially looks like this, where a user will create or update a PR. The GitHub workflow starts, and then the jobs that get spawned due to that end up dispatching to the self-hosted runners. So GitHub Arc, which is the actions runner controller that runs on the cluster, will spin up runner pods. So one for each workflow that we're going to end up running. So Linux and Windows for right now. And then those runner pods, when they get deployed to the cluster, they'll either schedule on a node that's already there, or it can also, if there's no nodes available and we're still within our quota, we can actually add new nodes. So it auto scales up and down, which is a pretty nice property, as the current system doesn't do that. So for the Linux workflows, the job gets scheduled on a Linux node by the Kubernetes cluster. And then within Linux, we do this, we set GitHub up to the workflow actually to spawn a container job, which adds a little bit of complication. But the big key with that is it enables building containers within the cluster using a tool like Kaneko. And then it also now enables anyone within the community to change the actual environment that the build is performed on. So right now, if you take the Linux build kite agents, they run a specific container image that can't be adjusted by anyone outside of Google. And someone has to build that. It's done using Google Cloud Build right now. So using this new setup, anyone can change the container image and anyone can just update it, building it on the cluster itself, which makes it a lot easier for the community to hack on it. On the Windows side, the job just gets scheduled and then we build it within the same pod. We would like to do the same setup as we do with Linux, but GitHub does not actually support being able to do the spawning. GitHub doesn't have support for running any containers within Windows workflows, which precludes us from doing what we want to do there. And then the GitHub infrastructure there handles reporting all the status. You get all of your logs as you'd expect. They end up being in a nicer format than BuildKite if you set it up correctly. Like you get individual steps rather than just this monolithic multi-megabyte log that you then have to parse through if there's any problems. And then depending upon if you merge, then we do potentially post-commit testing. What we're currently thinking of doing is running the post-commit testing on the same exact infrastructure, so doing it through GitHub Actions on the self-hosted runners, which provides a couple of advantages. Mainly, it's the same exact setup. There's been a bunch of problems recently where one of the build bots that tests the pre-commit configuration will be broken and the pre-commit won't be broken, or the pre-commit will be broken and the post-commit build bot testing that configuration won't be broken. So it's a lot of maintenance effort to try and keep those in sync that we'd rather avoid. And it also doesn't test any infrastructure problems. So if there's like some infrastructure problem where all the builds are failing on the checkout because something got misconfigured, that probably won't necessarily be caught on the post-commit testing. And we also want to make sure we're testing the infrastructure if we want to do something like only block on, or only warn on pre-commit tests that fail if main isn't broken or something like that. And then if you update, then we just go through the normal flow again.
So a couple of takeaways from this slide is one, this image, I know it's a bit of an eye chart, it's actually taken from a design document where we're documenting the design that Aiden and I are iterating on that we'll be sharing with the community shortly. So you don't have to worry if this image is too far away or not entirely accessible. It's just an excerpt from our actual documentation. I feel so proud to say that we're providing a system to LLVM that is documented. So really excited about that and feeling like a really good feeling, like, for once something went right. So that's awesome. And then the other thing is that this configuration that Aiden is describing is taken from the GitHub recommended sort of way to do self-hosted runners. And so there is already existing documentation as provided by GitHub about best practices that we're following here. So there shouldn't be too many surprises and already existing documentation, which again warms my heart a little bit. So let's continue.
Yeah, and then the other thing that we've worked on setting up is getting actual analytics set up. So we have the Grafana instance running in the cloud that's set up. This is an example dashboard that we built, mostly just as a proof of concept. These are some metrics that we think are probably going to be useful, like run times and queue times, and then success rate, like moving average success rates, which we think will be useful. But Grafana enables us to easily hack around just hack on the dashboard and change everything because all the data is there. So it just allows you to query it and put it into whatever format you want quite easily. So for the analytics details, so we're using a Grafana public instance hosted on the Grafana site. We might be able to get some more features if we self-host, but Grafana is AGPL, and we want to make sure we're in full compliance with the license terms there. So it's easier for us to make sure we're in compliance with that if we're using their hosted version of it. So right now it's an early prototype that needs refinement, but as you can see from the last slide, everything does work and we can pull all the data in that we need to. And then we ended up choosing Grafana because it has good documentation. It's pretty much an industry standard at this point, and it has a broad usage. So we're looking at tracking things like queuing delays on Linux and Windows, run times so that we can, which will correlate with queuing delays to make sure that jobs are actually taking a reasonable amount of time. Job success rates, so we can create metrics like if 95% of the jobs fail, then it's probably an infrastructure problem rather than problems with 95% of people's code. And then server utilization, just to make sure we're using resources appropriately and help with capacity planning.
And then the question marks are there to invite you to imagine other analytics that might be useful and suggest them to me or to Aiden or to anyone else involved in the infrastructure project.
Yep, and then
yeah, so next steps.
Thanks very much, Aiden.
Yep. So, and to give credit where it's due, Aiden built much of this. It's pretty awesome for somebody who just kind of introduced himself to me at the Euro LLVM dev meeting this year. And it's like, hey, I want to help out. And I'm an intern working on an unrelated thing on a different team at Google, but can I help? And I was like, sure, but don't get in trouble. And, and then here we are with new stuff that's like actually working and well documented and stuff. And I'm just very pleased with that. So thanks very much. In terms of next steps, we want to finish the first implementation of the analytics. I want there to be enough there that like it's worth having a conversation about. It's like if you put out something too early, I find oftentimes the feedback you get is mostly about the known flaws as opposed to the unknown flaws, right? And so if we put it out with only a few known flaws, then I think we get higher quality feedback back. And then also finishing the documentation. So just iterating on that and making sure that that's actually usable. The plan to launch this infrastructure is to do a shadow launch phase towards the end of the year. I actually, because we don't have analytics, I have nothing but intuition and like people's recall about this. Some people, I would say the betting is like 50-50 right now. Some people think that there is a holiday slowdown at all, because the working stiffs, don't contribute code as much because they're on holiday break. Some people think that the people that don't maybe hack on LLVM during their day job, or maybe they hack on LLVM during their day job and at night, have more free time, and like are with family and don't really want to be with family or whatever, and so they're like, you know what, I could like engage with this person, who is in my house right now and thinks that they should be in my house, or I could go upstairs and hack on LLVM. So like, we're a little bit curious if there is a holiday slowdown or not, but the thought was during a holiday slowdown, we could do a shadow launch where both sets of infrastructure are running. So right now, the infrastructure that we've built is running on a fork of LLVM that we're just using to test that things are correctly configured. But then we would want to commit the new stuff and and turn it on and have both infrastructure running. But the reason I want to do it during a slowdown is because that's going to double our machine resource usage, and so hopefully we can take some of the sting out of that by by not having the machines used as heavily. So I'm a little bit curious. Kind of wish we had analytics from last year to understand commit rate. I guess I could go look at just the raw like get SHA increments per day to try to understand if there is a slowdown or not. I probably will do that, thinking out loud. And then kind of once we're satisfied that the new thing, the not ready yet thing is now actually mostly ready, we'll turn off the deprecated thing, and that'll be your new system. So. Look for more details as they're finalized, and then we were thinking towards the end of the year of the slowdown of doing the actual launch timing. Future plans. So I think that a couple of times, even just while I've been involved with LLVM infrastructure, which is a little under a year now, there's been this sort of discussion that people have engaged with where they're saying, look, like, should we test this thing or not? I know there was like a big discussion around like, should some of the flang tests or flang changes that rely on parts of Clang, should that fire off and pre-submit, or the queuing delays got really bad on Windows, and so people were temporarily disabling the Windows pre-submit, and and there were feelings about that because when we turned it back on, then we would find a bunch of breakage, and so I think that there's this community discussion that I think is worth having about like, okay, well, given fixed costs that like is the expense that Google can bear or is willing to commit to this, the other knobs that we can turn are queuing delays, what do we cover in pre-submit, and like how do we divide the resources between Windows and Linux, Okay, so I'm out of time, but I think bringing data to that is really, going to drive the conversation and going to be a really important way to have a stronger, more informed conversation about that. And then we want to open the door to more community involvement. And lastly, with alerting and other things, having clear escalation pathways, I think would really help. So it isn't so informal where you're just pinging somebody on Discord and saying like, hey, it's broken, but like we should already know it's broken because our alerting told us, right? Like that would be really helpful. So quick list of credits here. I won't go through it, but thank you for your involvement. I only put the Googlers here. I know there's a lot of people that have been involved, outside of the community, and I wanted to thank them too, but have to move fast. And then, yeah, time for questions.
I'm just curious if it would make any sense to plug in the breadth of all the build bots that exist into this, so for a consistent look and feel, and maybe analytics as well.
Yeah, so that's one of the reasons that the analytics platform is like sort of deliberately open source here, is that we would love to have other contributions to it. And I definitely feel like, I'm not the queen of LLVM pre-submit. I'm just talking about Google's part in it and like what we feel like we can sustainably contribute. And so I would love it. Like for instance, I would love it if we pre-submit checked on Apple too, right? Like the other platform. But there's no option to, I have to use Google Cloud. I'm not, I would not survive sending an AWS bill to my manager for approval. So that's not an infrastructure I'm able to provide at Google, right? But this is definitely, I would love to have other participants plug into this and not just be solely responsible for this pretty important piece that I think that we're providing right now. Yeah.
Great work. Does your design allow for addition of other targets?
Yeah, so I mean, it's essentially just hooking into GitHub. So the part there would be implementing new workflows on the GitHub side, and then other people would be able to just register additional self-hosted runners on their infrastructure that would then be able to execute those jobs. So yeah, if you wanted to set something up on Mac or something on like AH64 Linux, you would just add self-hosted runners to the repository, and then you would be able to do that. So yeah, with like the cloud infrastructure that we're hosting, it would be pretty much specific to x86 and Windows and Linux, and maybe AH64 Linux if we ended up wanting to go there. But yeah, other people could add additional targets. There is a caveat that you can't add anything too esoteric because you need to be able to run the GitHub runner on it, and that is based on .NET because that's how Microsoft built it. So the platform support is somewhat limited, but most non-super esoteric platforms will support it.
So I think that in the far future, I envision a set of like community agreed upon standards for like what you could add to pre-submit, probably around like reliability and latency. Saying like your pre-submit bot is, takes less than half hour to complete and is 95% reliable. The only reason I don't advance those now is that I don't think our own system meets those criteria. So I would essentially be saying, the community gets no pre-submit, and that doesn't work. So, and we also have no analytics, so we have no way of knowing. But having built both of those things, I would love to have that kind of discussion and be able to invite other people in. Yeah?
You answered my question.
Okay, great. Beat you to the punch.
Let's thank the speakers again. Oh, you had a question? Go for it. Last question, maybe.
Hey. So how much faster is it gonna be now? Like, because I know the 36 speedy. Like I know the icons. Is it like more like 6 minutes, or what I mean? Like for a change that is fairly isolated, right? Like it's dominated by tests.
So we haven't tested it under production loads yet, right? Because we don't have budget to spin up 2 infrastructures. So can't say. I'm hoping. I don't think the builds will be any faster, but I'm hoping to get the queuing delays down. Yeah.
Hey, hi. So most of the system on Premerge right now assumes that like it runs always on all PR, mostly, right? There is some path filtering possible, but You mentioned that at some point we'll reach resource limits and we have to make trade-offs. One of those trade-offs is the ability to opt-in testing. It's like, well, especially when a PR is reverted for breaking, I don't know, a Power PC bot or something like that. That's where the connection to BuildBot that was mentioned earlier could be convenient, which is I would want just to rerun my pull request on this configuration that I don't have access to locally. And I know I broke a BuildBot, but if I cannot reproduce and I'm not sure, I will fix it. It's like, say,
I think a couple of things. One, I think that your take that some things don't need to be pre-submitted or only need to be pre-submitted in some things is a discussion that should be had by the community about.
I'm not saying they are not needed.
Yeah.
I'm saying we don't have the resources to do it.
Yeah.
It's like,
So I think that's another knob we can play with, but I don't as Google feel comfortable playing with that. Like I want that to be a public conversation, but I fully agree that's a knob we could play with. And like Chromium, which is my model of sort of really great pre-submit infrastructure, has these try-bots that meet that use case. I'm a developer, I'm working on Windows, but I want to test something on an esoteric platform. I can fire off a try-bot. I would love to see that. Pretty expensive. So, but maybe there's some middle ground we could find. Anyway, thank you very much.
Let's thank our speakers again, please.